Welcome to the next installment of my video lectures for managerial economics. As it says here, we're going to be taking a look at Chapter 11, the Q&As, and we're only going to be looking at Q&As 1 and 2. There's a separate video for Q&A 3 that is available to you. So we're taking a look at Q&A 11.1. Derive United Airlines' best response function if its marginal cost falls to $99 per unit. Given that American's marginal cost does not change, what is the new Nash-Cournot equilibrium? So in your textbook, this was previously reviewed. So just be aware that some of the information that you need has already been stated in the textbook. So make sure that you remember that some of the information has already been derived for you. But what I'm going to do is I'm going to actually go through some of the calculations that occurred prior to this. So if you remember from your textbook, the demand curve was Q is equal to 339 minus P. We needed to change that into an inverse demand function. So if we just, for example, add P to both sides and subtract Q from both sides, we get P is equal to 339 minus Q. Remembering that this is a duopoly, that United Airlines and American Airlines are the only two firms in this particular marketplace. This Q is just the quantities for United and for American. So we can rewrite our inverse demand function as 339 minus QA minus QU, where QA is the quantity that is being provided by American and QU is the quantity provided by United. So this gives us our residual demand function. So in order to find total revenue for American Airlines, it would just be the residual demand function multiplied by the quantity of A, because total revenue is equal to price times quantity. So we know that this is equal to price, and here's our quantity. We're only interested in total revenue for American Airlines, so it's QA. We multiply QA all the way through, and that gives us a total revenue for American is equal to 339 QA minus QA squared minus QA QU. Taking the first derivative of that, we get the marginal revenue for American is equal to 339 minus 2QA minus QU. Now we will do the same thing for United. So we start again with the original demand function. We convert that to an inverse demand function. And we recognize that Q is a function of QA and QU. Remember, this is a duopoly. The entire market constitutes just American Airlines and United Airlines. So QA plus QU equals Q. And we want to find out the total revenue for United. So we just take price and multiply by the quantity for United. And that gives us 339 QU minus QU QA minus QU squared. We take the derivative of that, which gives us 339 minus 2 QU minus QA. So we have the marginal revenue functions for both of these airlines. Now for American, remember that originally the cost was equal to, I believe, 147. And yes, I guessed correctly there. So if we want to figure out profit maximization for American, we would set their marginal cost, 147, equal to the marginal revenue curve. So we get 147 is equal to 339 minus 2QA minus QU. We add 2QA to both sides and subtract 147 from both sides, and that gives us 2QA equals 192 minus QU, and we solve for QA, so we divide both sides by 2, and we get QA is equal to 96 minus 1/2 QU. We do the same thing for United, but remember this problem stated that United's marginal cost falls to $99. So marginal cost equaling marginal revenue for United is going to be $99 equals 339 minus 2QU minus QA. We add 2QU and subtract 99 from both sides, and that gives us 2QU equals 240 minus QA, and we divide by 2, which gives us Q is equal to 120 minus 1/2 QA. So we have our best response functions for both of these firms. Now all we have to do is place one into the other. So in order to find out what's going on with United, we know that their best response function is 120 minus 1/2 of QA. So we know what QA equals. It's 96 minus 1/2 QU. We can place that into QA. So we end up with QU is equal to 120 minus 1/2 of 96 minus 1/2 of QU. We multiply that through and we end up with QU is equal to 120 minus 48 plus 1/4 QU. Solving further, we end up with, and basically we're subtracting 1/4 QU from both sides. And then simplifying this, we end up with 3/4 QU is equal to 72. And solving for QU, we get QU is equal to 96. So now that we know what QU is equal to, we can insert it here into the best response function for QA. So we have QA is equal to 96 minus 1/2 QU. We know that QU is equal to 96, so we place that in for QU. We simplify that out, and we end up with 96 minus 48 is what equals QA, and QA is equal to 48. Moving on to QandA 11.2, and I eliminated a portion of the text for this. So what I want to do is I'll just end up reading the introductory part to this. It was just entirely too long to fit on one slide, and I just thought it would be easier to read from the textbook a portion of the actual QandA 11.2. So let me start with, assume that Intel and Advanced Micro Devices, AMD, are the only two firms that produce central processing units, CPUs, which are the brains of personal computers. Both because the products differ physically and because Intel's advertising Intel Inside campaign has convinced some consumers of its superiority, consumers view the CPUs as imperfect substitutes. Consequently, the two firms' estimated inverse demand functions differ. For AMD, PA is equal to 197 minus 15.1 QA minus 0.3 QI. And for Intel, PI is equal to 490 minus 10 QI minus 6 QA. Where price is in dollars per CPU, quantity is in millions of CPUs. The subscript I indicates Intel, and the subscript A indicates AMD. We assume that each firm faces a constant marginal cost of $40 per unit, solve for the Nash-Cournot equilibrium quantities and prices. So we have, instead of having one demand curve, we have two separate demand curves. So we're going to do the same thing that we did previously, except we're going to be using these two distinct inverse demand functions. So we're going to calculate total revenue for AMD, marginal revenue for AMD, set that equal to marginal cost, figure out the best response function, and do the same thing for Intel. We'll take the price, we'll figure out total, we'll calculate total revenue, we'll calculate marginal revenue, and we'll set marginal revenue equal to marginal cost. So for AMD, that is the inverse demand function. So in order to get total revenue, we're going to have to multiply price, which is 197 minus 15.1 QA minus 0.3 QI. Multiply that by QA. So that will give us the total revenue for AMD. Multiplying QA through, we get total revenue of AMD is equal to 197 QA minus 15.1 QA squared minus 0.3 QA QI. We will take the derivative of this to get marginal revenue, and that yields 197 minus 30.2 QA minus 0.3 QI. So now we have marginal revenue of AMD. If we equate this to marginal cost, we will be able to get and solve for QA. That will give us our best response function. So marginal cost is equal to 40. Marginal revenue is 197 minus 30.2 QA minus 0.3 QI. All right, if we add 30.2 QA to both sides and subtract 40 from both sides, we end up with 30.2 QA equals 157 minus 0.3 QI. And if we divide by 30.2, we end up with QA is equal to 157 minus 0.3 QI divided by 30.2. So that's the response function for AMD. We'll go through the same process for Intel. Here's Intel's inverse demand function. We will want to calculate total revenue, so we will multiply by QI in order to get total revenue, because total revenue is price times quantity. So if we multiply this price by QI, that will give us our total revenue. We multiply QI all the way through, so we get the total revenue of Intel is equal to 490 QI minus 100 QI squared minus QA QI. Again, taking the first derivative will yield us the marginal revenue, and marginal revenue of Intel is equal to 490 minus 20 QI minus 6 QA. Marginal cost equaling marginal revenue being the profit maximizing condition. So we will have 40 is equal to 49 minus 20 QI minus 6 QA. If I add 20 QI to both sides and subtract 40 from both sides, I end up with 20 QI equals 450 minus 6 QA. And if I divide through by 20, I get QI is equal to 450 minus 6 QA, and that is divided by 20. So that gives me the best response function for Intel. And in order to calculate the actual quantities, what we do is we take AMD's best response function, all right, and we insert the QI in there, and we get that QA is equal to roughly 5 million CPUs, and the price is equal to $115.20. We do the same thing for Intel. We insert QA into where QI belongs, as we did here. And if we go through and solve that, we end up with QI equals 21 million CPUs, and the price is equal to 250.